Hello and welcome. My name is Faz and today I'm going to teach you something about the atomic structure. You've already read some basic stuffs about it in your previous classes like 6th and 7th class. But today we're going to just have a recap of everything that you've read in your previous classes in just 1 or 2 minutes, and then we're going to proceed to the things that you need to understand. So by the end of this video you'll be able to understand the exact reason why things react. You must have heard that reactions take place, chemical reactions take place. So why are they actually taking place? There must have been a reason, right, why Na and Cl must have come together and formed the table salt that we have, right? The thing that we use to make our foods taste better. Now, we're going to talk about that specific example, but before that, let me give you a quick recap of the atomic structure. You must have read about different types of models like Dalton's model and the ancient atomic model and the modern one, right? I'm not going to talk about that, but let me just give you a quick thing about this atom, right? So you've got a nucleus in between. Around the nucleus you've got so many electrons moving. Now here this is the nucleus, okay, and around them these are the electrons. So they are all revolving around this nucleus, and the path that you see, the circular path, is not actually something that you would see under a microscope. This is just an imaginary path, like, right? So basically today what I'm really interested in doing is to make you understand the chemical reaction part, because that is the application of the atomic structure. The reason we're reading atomic structure and all is to only understand why chemical reactions take place, and you'll understand the relation between the two in a few minutes. You have these shells named K, L and the other ones, K, L, M, N, right? And you have to know that each of these shells can accommodate only a particular number of electrons. Like the first one, the K shell, can accommodate only 2 electrons. The next one can accommodate only 8 electrons, right? And one of the things that I really want to tell you is that the reason why these elements are basically reacting with the other elements is because they want to complete octet. Now what is octet? Octet is the condition in which an element has 8 electrons in the outermost shell. Now I've just made the outermost shell. This is not the first shell. This cannot be the first shell because the first shell can accommodate only 2 electrons at most. I'm drawing only the outermost shell or the valence shell, and you'll understand later that the reason why this shell, the outermost shell of any atom, is so important is because this is the only shell that participate in the chemical reaction, okay? Now if you just try to look at this atom would be really stable. This would not want to be in any kind of bonding with any other atom of any other element, right? Because this is already very much satisfied with whatever it's having right now. If it had been like this, like if it had wanted like 1 more electron to complete its octet, it would want some other atom to come and help it being stable, right? So let me give you an example of this NaCl. Now this is the application part of atomic structure, right? Now what is NaCl? NaCl is a compound, right? And this is something that is really useful. Now Na is one element and Cl is another element, right? Now to understand how they came together and how they formed NaCl, which is really useful for us, we have to understand the atomic structure of Na and Cl. This is why we read atomic structure basically. Now if you want to make the atomic structure of any element, you first need to know the atomic number of that element, right? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here Na, you can always write this list down just to be on the safer side. Okay, Na is coming on the 11th position. That means it's having 11 atomic number, and Cl, it has 17 atomic number. Now what information we can derive out of it is that if we know that Na has 11 atomic number, the things that we can derive out of it is Na would also have, sodium would also have 11 electrons. This is how we denote electrons in short, right? So it is going to have 11 electrons and 11 protons. Protons and neutrons are basically things, are subatomic particles that reside inside of the nucleus of the atom, right? And so here you have these two things that you can understand from just this. If you know just this, the atomic number of any element, these are the 2 information that you can get out of it, right? Now again, we can do something from this information. We can make the atomic structure of sodium. Now since sodium is having 11, so we have to know how to arrange these electrons in the shells of sodium, right? So it would need at least these 11. If you want to write the electronic configuration of 11, the first shell will have a maximum of 2 electrons, the second one can have a maximum of 8 electrons, and the third one, and what's remaining is 1, because 2 plus 8 is 10, and what's remaining is 1, because we have to accommodate 11 electrons, so 1. So the last, so as I told you that the last or the outermost or the valence shell, the outermost shell, that is really most important in regards to the chemical reaction, right? Because this is the shell which is going to take part in the chemical reaction. And this electron, the outermost shell's electron 1, this electron which I'm going to make, so this is the nucleus, and here you accommodate 2 electrons, and here this in the second one you're going to accommodate 8, 5, 6, 7, 8. We'll need another shell. Now the remaining electron will be placed in the outermost shell, because the first 2 shells are already full. Now this is the electron that we are interested in, and this is the electron that is going to take part in the chemical reaction, right? And why does this take part in the chemical reaction? So the reason why this is able to move out is because, as you can see, this is really far away from the nucleus, and nucleus is the one which basically attracts all these electrons towards itself. So there is this force through which this nucleus is basically attracting and keeping to itself all the electrons. But since this electron is the farthermost electron from the nucleus, then the force of attraction that this nucleus has on all these electrons will be the least on the last one, because this is the furthermost electron from it.